just in case someone's not here, I've got it written. There we go. All right. So today, guys, we're looking at section 7.1 and 7.2. So in 7.1, we are going to look at ratios and proportions, which we'll get to in a minute. But first, let's talk about a ratio. A ratio is just a fraction. In other words, it's a comparison of two quantities using division. So I could say the ratio, for example, you see up here, we have some models. I don't know if any of you guys ever made any models when you were younger or not, but we could say that this particular model right here is 1 inch in that model represents 32 inches in an actual airplane. In other words, if when you measured, let's say this window right here, let's say it was 1 inch long in the model, that means that in real life, that window would be 32 inches long. That's what we call a ratio. An extended ratio, now a ratio compares two quantities. An extended ratio is 3 or more numbers. We'll talk about those in an example later on. Okay? And by the way, an extended ratio could be 4 numbers or 5 numbers. So let's look at example number 1, which actually is an extended ratio, because look how many things I'm comparing. 1, 2, 3. Says that the lengths of the sides of a triangle are in the extended ratio 3, 4, 5. The perimeter of the triangle is 84 centimeters. What is the length of the longest side? So, this is actually kind of tough. The only thing we know is that one side was 1 inch, then another side would be, one side was 3 inches, then another side would be 4 inches, and then another side would be 5 inches, right? Well, if you take 3 plus 4 plus 5, that doesn't equal 84, so that's not the answer. So how do we find the answer? So what I've done here is I've added a picture of a triangle, and you'll notice that this happens to be a right triangle, which I kind of picked on purpose. It turns out that if you use the Pythagorean theorem, which I hope you're familiar with, that is a 3, 4, 5 triangle. So this is a right triangle, but notice that I put an N next to each of these numbers because we really don't know what the amount is. We just know that the ratio has to be 3 to 4 to 5. So in order to solve this, we're basically going to say that, the side 3, or I'll call it side 1. How about that? Let's call it side 1. Side 1 is to side 2 is to side 3. In other words, 3n is to 4n is to 5n. This is the extended ratio for this particular problem, this triangle. That's all we know. However, you've been given some extra information here. You've been told that the sum of all of the things, that's called the perimeter, if you were to add these up, that has to equal 84. That gives us the key. And in fact, let me make sure I write this down before we move on. This is an example of an extended ratio. This right here is an extended ratio. Now I'm going to use the fact that the perimeter is 84 to get it. In other words, whatever 3n is, that's the length of side 1, plus 4n, that's the length of side 2, plus 5n, that has to equal 84. And so this is a very easy equation to solve, I think, because these are all like terms. 3n plus 4n plus 5n, what would that be? Well, that's 7 plus 5. So I think that's going to be 12n equals 84. And then how do we solve that? Well, we just need to divide both sides by 12. And so n is going to be equal to, in this case, I would just divide this using a calculator. I've already worked it out, though. The answer is 7. So, question. Is that the answer to my problem? 7 centimeters.
No, you still have to multiply 3, 4, and 5 by the 7.
Yeah, that's right. In fact, in this case, I can do all of those. In fact, we will. In fact, let's just do that, okay? But remember, I guess what I'm trying to say is, in this example, the question is, what's the length of the longest side? So let's go ahead and find that first, and then we'll go on and find all of them. So I know that n is 7. So if I want to know the longest side, that's this side over here, I just need to do 5 times 7. So that's 35 centimeters. This is the actual answer to the problem, 35 centimeters. Now I'm going to go ahead and find the other lengths like Alex said here, just to kind of prove a point here. So remember, if n is 7, then 3 times 7, that'd be 21. So that length is 21. And then 4 times 7, that's 28. So that length's 28. Anybody want to take a stab at knowing what 21 plus 28 plus 35? Anybody want to guess what that number is when you add those three numbers together?
84.
Yeah, it better be. That's exactly right. So this is a nice way to check your answer. But again, technically, this is the answer here. But we use this extended ratio to get to that answer. Okay, let's go ahead and move on. Unless there's a question, does anybody have any question on this one? Okay. All right, so here's the part that you guys are probably already very comfortable with, at least I'm hoping that you were very comfortable with. And this is something called the cross product property. The cross product property says that in a proportion, in fact, let me just talk about what a proportion is. Let me give you an example of a proportion. 2 is to 3 as 4 is to 6. This is a proportion. And all a proportion is it is a statement of equality between two ratios. And what the cross product tells us is if we cross multiply, in other words, if I take 2 times 6, it has to equal 3 times 4. Oh, by the way, what is 2 times 6? Well, that's 12. What is 3 times 4? That's also 12. So that's what this cross product tells us. If A is to B as C is to D, then AD is equal to BC. And again, over here, here's the example I did. I just did it for you, just so you can kind of see it happening in real time. So I hope you guys are familiar with that. I imagine that you are. I'm sure you've seen that before. That's something, when I used to teach middle school, that was something that I definitely taught in pre-algebra. So I'm going to do this first one, and then I'm going to have you guys try the second one, okay? So this first one, and by the way, you might want to have your calculator out. In fact, I'm going to grab mine just so I don't make a careless mistake. Like to keep those calculators handy, okay? So it says, what is the solution for each proportion? So for number A here, letter A, we've got 40 is to 140 as 700 is to X. That's how we would read that. And we want to know, what is X? That's what we're trying to figure out. So what we're going to do is we're going to use this cross product property. And again, I used to do this when I was a middle school teacher, and you guys might want to do it too, is you can literally take, I circled these two guys. And by the way, these are called the extremes. If we go back over here, that's what we call the extremes. I'm not going to ask you what those names are, but that's this one up here on the left and the low one here on the right. Those are the extremes. So 40x equals, and then you got to multiply by what's called the means. So now we're going to take 140 and we got to multiply that by 700. Now I'm not going to try to do these in my head and make a careless mistake. So I'm going to take that 140 times 700, and I get 98,000 for that one. That's a big number. And so then how do I solve this? Well, I just got to divide both sides by 40. So let's go ahead and do that. Let's divide this side by 40. Let's divide this side by 40. And again, I'm going to use my calculator here to make sure that I don't make a careless mistake. And I get that X is 2,450. And by the way, I can check that. The way I would check that is just put that 2,450 in for X, and then just cross multiply again and make sure that it works out, which it will. Okay. Now I just did that one. I'm going to give you guys just a second. I'd like you to try B. I'd like you to try to solve this one. It's a little bit harder because you have to do a little bit of algebra, a little bit more algebra than I did. But I would like you to find the answer to this one. I'm going to give you 2 minutes to try that one. So please find the answer for part B. All right, so I am going to ask somebody to see if they got an answer. I'm hoping that you guys got this one right. This one was a little bit harder than the first one. Let's go with, actually, I'll take a volunteer. But it has to be someone besides Alex, because Alex has already helped me out with one problem. Can anyone tell me an answer for what y is on part B? Jennifer says the answer is 2. What do you guys think? Can I get a head shake, yes or no? Yeah, I see some thumbs up. I agree. Jennifer, nice job, Jennifer. That is exactly right. Now, if you did not get 2, let me show you how to get 2, all right? So to get 2, again, we're going to do that cross product property. So we've got to take 3 times. Now, here's where a lot of students will make, oops, and I just made a mistake myself. Here's where a lot of students will make a mistake, is they won't include these parentheses. You have to take 3 times the quantity y plus 4. And then on the other side with the means, we're going to do 9 times y. So now we need to do the distributive property to get 3y plus 12. This should be a 12 right here, not 4. That's going to be equal to 9y. So then I would subtract 3y. That would give me 6y equals 12. And so you can clearly see that y is equal to 2. Nice job, Jennifer. That's a good question. And you got it. So any comments or questions on the cross product property? Pretty straightforward. And again, I think most of you are familiar with that. You will certainly, I hope you're familiar with it now. So, all right. So believe it or not, that actually completes section 7.1. So basically in section 7.1, we look at ratios, extended ratios, and then proportions. So I kind of hit all of those things. So what I'm going to do now real quick, if you guys don't mind, is I'm just going to launch a real quick little poll here. The poll is just to kind of see if, oops, I gave you the wrong poll here. Let me try that again. There we go. This one. Okay, so I've got 5 people that have voted here, and it looks like everyone got that one correct, so that's great. All right, so let's go ahead and move on. All right, so now we're going to move on to section 7.2, and section 7.2 is on similar figures. In fact, let me just start before we start getting into the nitty-gritty of what similar figures are. Let me just give you an intuitive idea of what a similar figure is. A similar figure, or similar figures, it's plural, these are just 2 figures that have the same shape, but not necessarily the same size. And we got to be careful here. Notice that I said not necessarily the same size. They could be the same size, and in that case, we call them congruent. But mainly what we're going to focus on is when we have 2 shapes that are the same, or 2 figures that are the same shape, but not the same size. So, for example, here you can see that this quadrilateral and this quadrilateral, they actually are the same shape, and we know that they're going to be the same shape for some reasons, but they are not the same size. So maybe, and I don't know what their scale factor is, but let's say maybe that this is 8 inches. This over here may be 4 inches. In other words, maybe this one's twice as big as that one, so the scale factor would be 2 to 1. So again, this kind of should feel like when I talked about ratios and models, like model airplanes or whatever. Now, you guys maybe didn't do models, and I'll be honest, I think I only did one when I was a kid. But does anybody do models? Just curious. Anybody ever done a model out there? A model tank or a model? I don't know if anyone does that anymore. Maybe I was the only one. Okay. All right, so key concept. 2 polygons are similar polygons if their corresponding angles are congruent. In other words, if angle B is congruent to angle H, angle C is congruent to angle I, angle A is congruent to angle G, angle D is congruent to J. So all the corresponding angles have to be congruent. And furthermore, the lengths of their corresponding sides have to be proportional. And just to keep this simple, if this was 3, and let's say that was 6, if this was 2, that'd have to be 4. Because 3 is to 6 as 2 is to 4. If we were to cross multiply here, you're going to get what? 12 equals 12. That's what proportional means. And it turns out that all 4 pair of corresponding sides would have to be proportional. So in symbols, here's what we're saying. All of the corresponding angles are congruent. So corresponding angles are congruent. And then corresponding sides are proportional. And we just talked about what a proportion is. Let's look at an example. Okay, this is kind of an easy example because we're actually not going to find any numbers. We're only going to just use that definition that we just saw for similar polygons. And in this problem, it says that we got 2 triangles, and it says that they are, here's the word, or here's the symbol for similar. For similar, we use, it's called a tilde. Now, we've seen a tilde before, and that's on the congruent symbol, right? A congruent symbol is an equal sign with a tilde on the top. It turns out that congruent triangles are also similar. If they're not equal, like in this case, you can clearly see that those 2 triangles are not the same size, so they can't be congruent. But they are, in this case, similar. And the good news is if you have a similarity statement like this, you can once again, like when we did congruent triangles, just use their corresponding letters in the same order. So for example, I'm telling you that angle M has to be congruent to angle S. So here's angle M right here. It has to be congruent to angle S based on this similarity statement. Also, angle N has to be congruent. Well, angle N was the second letter, so it's got to be the second letter over here. So that's angle R. So angle N, that's this angle, has to be congruent to angle R. And finally, angle P has to be congruent to angle T. So that's this third angle and this third angle here. So those are the congruent corresponding sides. Now we need to do the same thing. Now we're going to talk about the corresponding sides. So let's do that in a different color. So again, I'm going to use the same trick. I'm going to use the first two letters. So segment MN, that's this guy right here. Segment MN has to be paired with the first two letters of the second triangle. So that's SR, SR. So I'm telling you that this side has to be paired up with that side. I'm going to use a different color again. Now, next, I'm going to use the last two letters. So that's NP over RT. That was the last two and the last two. So NP, that's this long side, and then RT, that's that long side. And then finally, let's do one more here, and let's do it in, I guess, blue. I'm going to use the first and the third. NP, that's this guy, has to be paired with ST. That's this guy here. So this, if you look back at our previous slide here, also I've just copied basically this, except in this case, this was a quadrilateral, so that's why there's 4 of everything. Over here, we're dealing with triangles, so there's only 3, right? So we had 3 here, and then we had 3 here. Remember, this is what we call an extended ratio, okay? Now, these are the types of questions you will see on the homework, so hopefully that makes sense, okay? If you have any questions, let me know. All right, so let's talk about scale factor. It says, give the scale factor for the polygons and find the value of x. So I guess I should have maybe included this in my directions. We're going to assume that these triangles are similar. We're going to assume that these triangles are similar, and I should have written that in the directions. And they kind of look like they're the same shape and the same size, although it should be stated in the directions. So how are we going to do that? It says triangle XYZ, so XYZ, so XYZ, that one. And triangle EFD, that's that one there. In other words, if I say that triangle XYZ is similar to triangle EFD, that's how I would write it symbolically if they were similar. And so now what I want to do is I want to try to compare some things. And we're talking only about their sides right now. So XY, well, what would XY have to be paired with? Well, it's the first 2 letters, so it's going to be the first 2 letters over here, so it's going to be EF, so that's going to be 10. And actually, let me actually step back a step here. Let me not put the numbers in here yet. We'll get that on the next step. So that's going to be EF. I'll call it EF. Okay. The next one is, so let's hear, we want this guy here, which is YZ. So that's the last 2. So YZ has to be paired with the last 2 over here, which is FD. So here's my proportion that has to be true if these guys are similar. Now I'm just going to substitute the stuff in that we know. What's XY? It's 15. What's ED? It's 10. What's YZ? It's 14. What's DF? It's X. So now we can go ahead and cross multiply and get our answer. So that's going to be 15x. I'm going to cross multiply this way. And then I'm going to cross multiply this way. I hope you guys can do 10 times 14, which is 140. And then again, just to be careful here, I'm going to be very careful with my calculator. I'm going to divide 140 by 15. Ooh, this one doesn't come out so nice. It ends up being 9 1/3, which isn't an answer you would probably get in your head. So this is where you would definitely want to try to use a calculator. 9 1/3. Oh, by the way, I just found X, but I still haven't figured out what the scale factor is. The scale factor, I'll write it over here. I'll call it, I'll just write it out. The scale factor means it's basically just asking you, what's this ratio? Well, what is this ratio? Well, it's 15 to 10, which hopefully you guys know that that would reduce to 5 goes into 15 3 times and 5 goes into 10 2 times. So I would say that the scale factor here is 3 to 2. Another way you could write that is 3 colon 2. This is another equivalent way of writing it. So here's our scale factor, 3 to 2, and there's the value of x. I guess I kind of did those in the wrong order. Comments or questions on that example? Okay, we're almost done. Oh, actually, you know what? I have another poll question for you. This is a little bit trickier, so we'll see how you do on this. Please answer the poll question. Okay, so I'm going to close the poll here. So if you haven't answered yet, go ahead and answer. Okay. So I'm going to end the poll here, and I'm going to show you what the correct answer is. I'm going to actually go back. Remember I said this was the answer to the problem, 9 1/3. 9 times 3 is 27, plus 1 is 28 over 3. That is the correct answer to the poll question. The correct answer is not 9. Please note that this does not equal 9, okay? Does not equal 9. Anyways, okay, last thing here. We have one more example, and this is the most important example of all the problems I've done. This is one where you definitely need your calculator though, so hopefully you've got your calculator. We're going to wrap it up here with this final problem, then I will give you the exit slip, and then we'll move into our support time. During the support time, you guys are completely encouraged to stay on here. We could start working on homework together if you wanted to. I could take questions on the test review that I posted last week, or whatever questions you might have about today's lesson. But before we do that, I want to look at this last example. And this is why mathematics, one of the reasons I should say, it's the reason, it's one of the reasons that mathematics is so important. Let me just kind of get to the gist of this. The gist is this. Using similar figures, we can measure things indirectly. What I mean by that is, based on shadows, you could actually approximate the height of that telephone pole without having to climb to the top of that telephone pole and using, some way to measure that. In fact, this same technique basically was used thousands of years ago. They actually approximated the distance from the Earth to the Moon, which I mean, we could all, use Google and look that up, right? I want you to think about thousands of years ago, before there was internet or calculators. How in the world would they figure out how far it is from the Earth to the Moon? Well, they actually used geometry to do that. Anyways, let's look at this. This is obviously a much easier example than that. So it says a telephone pole casts a 24-foot shadow. So here's that 24 right here. There's that shadow. Belinda, who is 5 feet 8 inches, she casts a 7-foot shadow. Which is the closest height of the telephone pole? So, and then this is multiple choice, so you can pick. But I just want to forewarn you, the exact answer here that we're going to come with is not any of those. So we're going to have to do a little bit of rounding. That's why I picked this problem. So what we're going to do first of all is we need to recognize that these are similar triangles. In other words, I'm saying that this triangle here with Belinda is the same shape as that triangle over there is with the telephone pole, but they are not the same size. So, since they are similar triangles, so I'm going to put second, the sides have to be proportional. So that's that word proportion again. In other words, I'm telling you that, what's her name again, Belinda? Belinda, her height is to her shadow as the telephone's height, and it's actually a telephone pole, is to its shadow. This is the big idea right here. Her height is to her shadow as the telephone pole's height is to its shadow. Now, and please keep in mind, this is not a unique proportion. There's a different way we could write it, but I don't want to talk about that right now. We'll talk about that at another time if you'd like. So now we can start plugging things in. What is Belinda's height? Well, it's 5 feet. Oops, and I just wrote that incorrectly. I don't know if you guys know this or not, so this might be a good chance for a teachable moment. These are you use one little like tally mark there to make that feet, and then you use 2 like a double quote to be inches. So her height is to her shadow as the telephone's height, and I'll just put feet, is to its shadow. Now we have one problem here before we can move forward. Does anybody see what the problem is? And this is something that's very important. If we don't deal with it, it's going to give us a major headache as we come up with our answer will be incorrect. Does anybody see what's going to be wrong here if I just go ahead and cross multiply at this point?
It's 5 foot 8 inches, and it all needs to be in feet.
Yep, it's exactly right, Alex. Guys, there's inches in this one. Everything else is in feet. So what we need to do is we need to convert this. We got 2 options, guys. We can either convert everything to inches, or we can convert everything to feet. It's one or the other. And I'll be honest, I think for most students, this would probably be the easier route to go, but I'll let you guys decide. I want you in the chat right now, I want you to type I for inches or F for feet, please, just to give me feedback. I will do it either way you want, but I need some feedback. What do you guys want to do? Okay, so one person's responded. Okay, all right, couple right. Oh, it's even. I've got inches and feet. Feet. Okay, feet's winning. I'm going to go with feet. Okay, fine. Feet it is. We're going to do feet. So what you need to do, in fact, I would just encourage you to think about how you would do that. How would you convert this into just feet? Well, to deal with this 8 here, it becomes 5 plus 8 over, does anybody want to take a guess on what number I'm going to put below the 8? Now the answer is 12, because there are 12 inches in 1 foot. In other words, this is going to be 5 and, well, 4 goes in there twice, 4 goes in there 3 times. So in other words, what I need to put in here is 5 2/3 instead of this 5 and this 8. And now I've got it set up. I'm going to ask you now, would you please determine the answer? Would you go ahead and cross multiply? Now remember, don't put this 5 and 8. You have to put this 5 and 2/3. Please feel free to use a calculator as well. In fact, I'm going to do the same. Okay, so when I use my calculator to do this, I got 19.429. I rounded it. I didn't go all the way out. This would be, if assuming that these were exactly true, this is, this would be the answer in feet. And so now what we need to do now is just pick the answer that's closest to that. Hopefully you guys would realize that 20 is the closest to 19.4. And so that tells us, Belinda, without actually having to get up on the top of this telephone pole or anything like that, if she uses these similar triangles, she can determine that that telephone pole is roughly 20 feet tall. So this is an example of indirect measure, which I think is one of the best applications in the real world of using geometry. All right, guys, so we are almost done now. I'm going to actually stop recording. I'm going to send you the exit slip that I'd like you guys to give me your feedback on.